All right, let's dive right in. Welcome to this explainer, where we're about to take a seriously mind-bending journey. We're going to zoom all the way out to the most terrifying, massive explosions in the universe, and then we'll zoom all the way back in to the fragile and honestly deeply lonely reality of human space exploration.
So you gotta wonder, what connects a prehistoric mass extinction, a stray dog from Moscow named Laika, and literally the atoms inside your own body? I know, it sounds like totally random trivia. But as we're gonna see, they're all bound together by the incomprehensible scale and power of the cosmos. Section 1. Explosions in the dark. The universe at its most violent. To start, try to imagine a scale our human brains just aren't built to process. Think about holding a hydrogen bomb directly against your eyeball and detonating it. Insanely bright, right? Well, if our sun were to go supernova, watching it from Earth would be a billion times brighter than that hydrogen bomb on your eye. That is how wildly powerful these cosmic detonations truly are. They can literally outshine entire galaxies made of hundreds of billions of stars.
So how does a star actually get to that point? Let's look at the fusion stages of a dying star. For roughly 90% of its life, a star is in this stable balance, just happily fusing hydrogen. When that runs out, it moves to helium, which lasts about 1,000,000 years. But then the pace really accelerates. Carbon and neon? Gone in 1,000 years. Oxygen and silicon? Burned through in mere months. And then it hits iron. Iron doesn't release energy when it fuses, it actually absorbs it. So the star's internal engine just completely stops, and gravity takes over in a matter of seconds.
Which brings us to an absolutely staggering number, 10 to the 58th power. As that core collapses, electrons and protons are crushed together to form neutrons, and in that single moment, 10 to the 58th power neutrinos are released. Neutrinos are basically these massless, ghost-like particles that barely interact with anything at all. But the core becomes so unbelievably dense, we're talking trillions of times denser than lead, that these ghost particles actually get trapped. Their kinetic energy triggers the shockwave that blows the entire star apart. So the biggest explosions in the universe are actually caused by the most humble, near-massless particles imaginable. Section 2. Monsters of the Cosmos. Supermassive black holes. Sometimes when a star dies, it tears a literal hole in reality. Which brings us to the sheer terror of Phoenix A star, located 8.5 billion light-years away. This isn't just your standard black hole. It's a monster 100 billion times more massive than our sun. To even try to wrap your head around its size, the event horizon, the point of no return where not even light can escape, is roughly 100 times the entire distance between our sun and Pluto. It's literally larger than some entire galaxies. If that wasn't terrifying enough, think about this: 71 days. If you were in a spaceship traveling at the absolute speed limit of the universe, the speed of light, it would still take you 71 continuous days just to complete one single loop around the edge of Phoenix A star. And honestly, the scariest part? It's still eating. It is still growing. Section 3. When space strikes Earth. The cosmic threat. Now, it's pretty easy to look at supernovae and black holes as these distant, abstract concepts, but what happens when they strike our own fragile planet? We know a supernova can be lethal from up to 150 light-years away. Here is exactly how that plays out. Step 1. High-energy cosmic rays from the exploding star hit our atmosphere. Step 2. They break apart nitrogen molecules, which then bond with oxygen. Step 3. This process completely shreds our protective ozone layer. And finally, Step 4. Highly charged, heavy particles called muons rain down, irradiating life on the surface. We actually believe this exact sequence wiped out a third of Earth's marine megafauna 2.6 million years ago. Shallow water animals were essentially cooked by radiation, while the deep water creatures were shielded.
So how do we know this happened exactly 2.6 million years ago? Well, that happens to be the exact half-life of an isotope called iron-60. Iron-60 is basically only produced in supernova, and scientists have found layers of it sitting right at the bottom of the Pacific Ocean. It is literal, physical proof that a dying star rained radioactive fallout down onto our prehistoric ancestors. Space is incredibly hostile, for sure, but what if the threat was much closer to home? Like, what if our own moon just started tumbling toward Earth? Well, coastal cities would be instantly consumed by massive, shifting ocean tides. Earthquakes and volcanoes would just become everyday events. But here's a fascinating twist. Before it could actually crash into the surface, once it got about 11,000 miles away, Earth's gravity would completely tear the moon apart. Any survivors left down here would look up and see a gorgeous, shimmering ring system of moon dust around the Earth, kind of like Saturn's.
It's a strangely beautiful outcome from absolute destruction.
Section 4. Our fragile space journey. Alone in the void. We've talked a lot about the raw, destructive power of the universe, but let's shift gears and look at our deeply human, incredibly fragile attempts to step out into it. Just imagine the sheer silence of this moment. In 1984, astronaut Bruce McCandless tested a jetpack system by floating 100 meters away from his space shuttle. No rope, no tether, just a human being hovering in the infinite, pitch-black abyss. When asked about it later, the thing that terrified him the most wasn't the drop or the void itself. It was how intensely, deeply cold he became the moment he drifted away from the ship.
You know, our early steps into this cold void required immense, truly heartbreaking sacrifice. Take Laika's tragic journey. Before humans ever went up, the Soviets used a stray dog plucked from the streets of Moscow. Back in 1957, they strapped her into a capsule the size of a washing machine, fully knowing it was a one-way trip. During the launch, her heart rate tripled in sheer terror. The cabin temperature spiked to 105 degrees Fahrenheit, and after just 6 desperate hours in space, Laika's heart stopped. She literally gave her life so we could learn to conquer gravity. Fast forward a few decades, and even our robotic explorers face this kind of lonely end. After 14 resilient years traversing the surface of Mars, the solar-powered Opportunity rover was engulfed in a massive Martian dust storm. Choked of all sunlight, the rover sent back one final poetic data transmission to Earth. My battery is low and it's getting dark. Really let that sink in. A machine dying alone in the dust millions of miles away from its creators. But despite all the hostility of the void, it does give us incredible perspective. In 1990, the Voyager 1 probe was 4 billion miles away from home, when Carl Sagan convinced NASA to turn its cameras backward. It caught Earth as this tiny, single pixel of light in the darkness. Sagan wrote, "The Earth is the only world known so far to harbor life. Look again at that dot. That's here. That's home. That's us." And attached to the side of that very same Voyager probe is humanity's delicate attempt to leave a permanent mark. Earth's time capsule, the golden record. If our species is ever extinguished, this record might be the absolute last evidence we ever existed. It contains our greatest music, the sounds of nature, greetings spoken in dozens of languages, and over 100 expertly curated images. It is our story, sailing quietly through a violent universe.
Section 5. The Cosmic Connection. We are the universe.
So, how do we pull this all together? The macro-scale destruction of exploding stars and the micro-scale fragility of a dog in a capsule or a record on a probe. Well, they are intimately, permanently linked. Even our supposedly stable home is caught up in this shifting cosmic dance. Like, did you know the moon is actually moving 1.5 inches away from us every single year? Because of this, Earth's rotation is slowing down. In 1 billion years, a single day on Earth won't be 24 hours. It's going to stretch to 28 hours. The mechanics of the cosmos are slowly but constantly altering our daily reality.
Which brings us to the stardust reality. We aren't just observing this violent universe, we're literally a byproduct of it. 4.6 billion years ago, it was the shock wave from a nearby supernova that triggered the collapse of a gas cloud to form our very own solar system. That means every single breath of air you take contains atoms forged in the heart of a dying star. Every glass of water you drink traces its origin straight back to the Big Bang itself. So, here's a final thought to leave you with. If the iron in your blood and the calcium in your bones were literally forged in the explosive death of a star, if you are truly made of stardust, then are human beings, armed with our astronomy and physics, simply the universe's way of finally getting to observe itself. Think about that the next time you look up at the night sky. Until next time, keep observing.